Hello and welcome to Alpha Omega General Training videos. We will delve into radiation modeling using Ansys Fluent software in this tutorial. Ansys Fluent is a computational fluid dynamics tool that offers advanced radiation modeling capabilities. This tutorial is designed to help students, researchers, and engineers improve their expertise in this area. Let's get started exploring the fascinating world of radiation modeling. In Ansys Fluent, radiation models are used to simulate the transfer of thermal radiation, which is a key factor in many engineering problems. Fluent offers several radiation models to choose from, including the Rosland, P1, discrete transfer or DTRM model, surface to surface or S2S, discrete ordinates DO model, and Monte Carlo MC radiation model. Each model has its own strength and is suitable for different types of problems. For instance, the DO model is a general purpose model that can handle complex geometries and non-gray radiation, while the S2S model is best suited for problems with participating media and gray radiation. The P1 and Rosland models are more simplified and are typically used when the medium is very optically thick or thin, respectively. These models allow engineers to simulate the effects of thermal radiation accurately, helping them optimize their designs and improve the performance of their products. Radiation plays a significant role in non-destructive testing (NDT), which is a method used to inspect and evaluate the properties of material, component, or system without causing damage. Two common NDT methods that utilize radiation are radiographic testing and gamma ray testing. In RT, X-rays or gamma rays are passed through a material to capture an image of its internal structure on a detector. This technique is effective in detecting internal flaws such as cracks, voids, or enclosures in materials. Gamma ray testing, on the other hand, uses gamma radiation, which has high penetration power and can be used to inspect dense materials. This method is commonly used in industries such as oil and gas, where pipelines and other equipment are inspected for corrosion and other defects. Both methods provide valuable information about the internal condition of a test object without the need for physical disassembly or destruction, making them cost effective and efficient. However, due to the hazardous nature of radiation, these techniques must be performed under strict safety regulations. Remember, the key benefits of using radiation in NDT is its ability to reveal hidden defects, ensuring the safety, reliability, and longevity of materials and structures. Radiation technology is a powerful tool in process control due to its non-invasive and non-destructive characteristics. It is used in various industries such as oil, gas, mining, and manufacturing. One common application is in level detection. Radioactive sources and detectors are placed on opposite side of a vessel. The amount of radiation detected is inversely proportional to the level of substance in the vessel, providing real-time, accurate level measurements. Another application is in density measurement. By passing a beam of radiation through a material and measuring its absorption, the density of the material can be determined. This is particularly useful in industries like mining and paper manufacturing. Radiation is also used in thickness gauging in industries like steel and plastic manufacturing. Maintaining a consistent material thickness is crucial. Radiation gauges provide precise real-time measurements, improving product quality and reducing waste. Radiation technology thus enhances process control by providing accurate real-time data, improving efficiency, safety, and product quality. I'm here to tell you about the fantastic capabilities of radiation models in Ansys Fluent. Ansys Fluent is a powerful tool for computational fluid dynamics simulations, and its radiation models are particularly impressive. Here are a few reasons why you might want to consider using them. Variety of models. Ansys Fluent offers a wide range of radiation models, including the discrete ordinates, the P1 radiation, the Rosland radiation, the surface-to-surface radiation, and more models. Each model has its unique advantages, allowing you to choose the one that best suits your needs. Accurate and reliable. These models are designed to provide accurate and reliable predictions for radiation heat transfer, which is vital in many engineering applications. They take into account the effect of scattering, absorption, and emission of radiation, ensuring a comprehensive simulation. Flexible and customizable. Ansys Fluent allows you to customize the settings of these models to match your specific application. You can adjust parameters such as absorption coefficient, scattering coefficient, and emissivity to fine-tune your simulations. Integrated with other models. The radiation models in Ansys Fluent can be used in conjunction with other models such as turbulence models and heat transfer models. This allows for a more comprehensive simulation of complex physical phenomena. User-friendly interface. Despite their complexity, these models are presented in a user-friendly interface that makes them accessible to engineers of all levels of experience. The software provides clear instructions and prompts to guide you through the setup process. Extensive documentation and support. Ansys provides extensive documentation for its Fluent software, including detailed descriptions of its radiation models and tutorials on how to use them. In addition, they offer excellent customer support to help you get the most out of their software. In conclusion, the radiation models in Ansys Fluent are powerful tools for simulating radiation heat transfer. They offer a combination of accuracy, flexibility, and user-friendliness that is hard to beat. Whether you're an experienced engineer or a student just starting out, I would highly encourage you to give them a try. Now let's enter the Ansys Workbench software. Ansys Fluent is a comprehensive software suite for computational fluid dynamics. It includes several tools such as Design Modeler, Space Claim, Ansys Discovery, Ansys Meshing, and Fluent Meshing. Okay, here you can see a solved project. The first step is the geometry. By right-clicking on this option, you can see the Design Modeler, Space Claim, and Discovery. By clicking on them, you would enter this software to design and modify your geometries. The software offers advanced geometry modeling capabilities that allow users to create, modify, and manage 3D models with precision. Also, we have the Ansys meshing. This is Ansys meshing. The geometry will import to Ansys meshing to generate high quality elements. Okay, if you right click on it and hit the edit, you can enter into the Ansys meshing software, or you can drag it from the component systems to project schematic window, and here you have the Ansys meshing software. Also, there's another software named Fluent meshing just under the Fluent. You can also drag it into this window, and here the first option is Fluent meshing. Ansys meshing and Fluent meshing are renowned for producing high quality mesh using advanced algorithms, which enables professionals to simulate complex fluid flow problems with confidence. Okay, now to enter the Ansys Fluent software, here I right click on the solution, edit, and after a few moments the Ansys Fluent software will be loaded. Our software provides you with a wide range of meshing options that are sure to impress you. These options are designed to meet your simulation requirements and enhance your overall user experience. Additionally, we offer advanced tools for checking mesh quality that are truly remarkable. With these tools, you can gain a complete understanding of your simulation's accuracy and identify potential issues before they become major problems. This gives you the freedom to concentrate on achieving the best results for your project without worrying about the accuracy of your simulation. With our top-notch meshing options and quality checking tools, you're sure to experience the ultimate simulation software experience. Okay, if you go to the first step, which is general industry line, you can see the check button and also the report quality. By clicking on the check, here in the console, you can check the elements of your mesh file and also report the quality of your elements by different parameters. Looking to elevate your simulation to new heights, Fluent is the answer. This software is widely recognized for its exceptional meshing capabilities, but that's just the tip of the iceberg. With Fluent, you'll have a wealth of robust tools at your fingerprints for visualizing geometry, mesh, and graphical results, such as contour, vector, and streamlined plots. These tools are not only incredibly user friendly and adaptable, but they also offer an exciting way to engage with your data. With Fluent, you can gain deeper insights and make more informed decisions, unlocking unparalleled outcomes. Okay, here you can see the geometry of the solution. By clicking on the option display mesh, you can select your desired boundary conditions here. For example, here I can disable the wall internal space, and now we can see the internal parts much better. Okay, the panel, reflector, casing, heat source, and we can also enable or select all of them. By increasing the transparency, you can see all of them and also the internal parts at the same time. Okay, Now I want to show you how you can see the elements, surface elements in the Ansys Fluent software. By enabling the edge, here you can see total elements on the surfaces of the boundaries. You can again disable some boundaries. And as you can see, we have a high quality mesh file. Alright, Ansys Fluent is a widely recognized software that offers a broad range of versatile models to address a wide variety of physical phenomena. The software boasts an impressive suite of turbulence models. If you double click on the models, you can see most of the models available in Ansys Fluent. The software suite boasts an impressive suite of turbulence models, including Reynolds average, Navier-Stokes, large eddy simulations (LES), and direct numerical simulation (DNS). Multiphase flow simulations are enabled through the software's Eulerian, Lagrangian, and volume of fluid and mixture models. Furthermore, Ansys Fluent incorporates heat transfer models including conduction, convection, and radiation to provide a comprehensive solution for CFD simulations. The software also offers various combustion models such a finite rate, eddy dissipation, partial premixed, and premixed to aid combustion simulations. Additionally, Ansys Fluent provides species transport and reaction models for chemical species simulations and various spatial models like acoustics, porous media, and discrete phase models. Ansys Fluent's impressive array of features and functionalities makes it a comprehensive and reliable tool for CFD simulation. Ansys Fluent provides several models to simulate the effect of radiation in a system. These include the discrete ordinate model. Here, by double clicking on the radiation or selecting it and hitting the edit, you can see the whole models available for the radiation. Discrete ordinate model, P1 model, Rosalind model, discrete transfer model, and surface to surface model. Each model has its own strengths and weaknesses, and the choice depends on the specific requirements of your simulation. These models help in simulating the energy transfer due to electromagnetic radiation, which is crucial in many engineering applications like combustion, heat transfer in furnaces, solar panels, and etc. Alright, if you're looking for powerful tools to simulate radiation in your engineering projects, Ansys Fluent is the way to go. With its various radiation models, you can accurately predict heat transfer and energy exchange in optically thick and thin media, as well as between surfaces. The Rosalind radiation model is a great option for very optically thick media, while the P1 is more accurate for moderately optically thick media. The discrete transfer radiation model is the most accurate for optically thin media, but it's also more computationally expensive. If you're dealing with surface to surface radiation between opaque surfaces, the surface to surface radiation model or S2S is the way to go. And if you need a model that can handle both optically thin and thick media, as well as anisotropic scattering, the discrete ordinate radiation model or DO is a great choice. Finally, if you need the most accurate model that can handle complex geometries, anisotropic scattering, and wavelength dependent properties, the Monte Carlo radiation model is the best choice. Overall, Ansys Fluent offers a range of radiation models to suit your specific needs, whether you're working with optically thick or thin media or need to simulate radiation between surfaces. With Ansys Fluent, you can trust that your simulation will be accurate and reliable. I'm really delighted to discuss the powerful pressure velocity coupling scheme that Ansys Fluent offers. Ansys Fluent is an incredibly powerful tool for CFD simulations. It's highly respected in both academia and industry, and it's used by professionals all over the world. Fluent offers a wide range of features and capabilities. It has advanced pressure velocity coupling methods like simple C, piezo, and cooled, which provide accurate and efficient solutions for the Navier-Stokes equations. Plus, it offers various spatial discretization methods, including upwind schemes, central differencing schemes, and higher order schemes, allowing for a fine-tuned balance between accuracy and computational effort. So, if you're looking to solve complex fluid dynamics problems, I highly recommend you consider using Ansys Fluent. It's really a game changer. After that, before we go to the run calculation to start the simulation, here we need to initialize our project. As you can see, we have two methods. The standard initialization method initializes the flow field by setting flow variables to user-specified constant values throughout the computational domain. This method is often used when you have a good estimate of the flow field. On the other hand, the hybrid initialization method initializes the flow field by interpolating values from the boundary conditions. This method is particularly useful when you do not have a good estimate of the flow field. It can provide a better starting point for the solver, especially for complex flows, leading to faster convergence. And finally, we have the run calculation section. Here, we have to enter the number. After clicking on the calculate button and running a simulation, Ansys Fluent offers a variety of options to analyze and visualize the results. These include contour plots, vector plots, and path lines, which help in understanding the flow patterns in a fluid. Additionally, Fluent allows the creation of animations which are useful in presenting and understanding transient behavior. Okay, here if you close the solution, you can see the results. Under the results, you have the surface section to define planes, the lines, points, and isosurfaces. Here under the graphics, you can define the mesh file, contour, vector, pathline, and particle tracking graphical results. Also, there are various type of plots, and here you can export animation from transient simulations. Here I open the predefined contour. It will display the temperature, static temperature on X coordinate 6 surface defined. Okay, this is the temperature variation in this plane. Here I want to define a mesh file. Okay, that's a proper view. Then here in the scene, I want to select both the mesh and contour to take a look at them both at the same time. Okay, save and display, but now we can't see the contours, so we need to increase the transparency of the mesh file, and that's it. Furthermore, Fluent provides quantitative post-processing tools that allow users to calculate derived quantities, create report definitions, and set up monitors. These tools enable users to extract specific data of interest, such as forces on a body, average temperature in a region, or flow rate through a boundary. Here, if you open the reports, you can see the different kind of reports from discrete phase, fluxes, forces, and surface and volume integrals, which you can select different parameters and calculate them on these different sections. Fluent's post-processing capabilities are highly customizable, allowing users to tailor the output to their specific needs. Overall, Ansys Fluent's post-processing capabilities are essential in interpreting the results of CFD simulations, enabling users to gain insights into their simulations and make informed design decisions. It's important to note that the best way to learn about these capabilities is to use the software and explore its features. Okay, now I want to show you the figures extracted from this project.